100 facts about integration. Integration is a fundamental concept in mathematics, particularly in calculus, with applications across various fields. Here are 100 facts to help you understand it better. Basic concepts. 1. Indefinite integral. The antiderivative of a function, representing the family of functions whose derivatives are the original function. 2. Definite integral. The net signed area under the graph of a function over a given interval. 3. Integration by parts. A technique for integrating the product of two functions. 4. Integration by substitution. A technique for simplifying integrals by substituting a new variable. 5. Riemann sum. An approximation of the definite integral using rectangles. 6. Fundamental theorem of calculus. Connects differentiation and integration, linking the definite integral of a function with its antiderivative. 7. Integration by partial fractions. A technique for integrating rational functions by decomposing them into simpler fractions. 8. Improper integral. An integral with infinite limits of integration or a discontinuity within the interval. 9. Double integral. An integral over a two-dimensional region. 10. Triple integral. An integral over a three-dimensional region. Applications. 11. Area. The definite integral can calculate the area under a curve. 12. Volume. Double and triple integrals can calculate the volume of three-dimensional objects. 13. Average value. The average value of a function over an interval is given by the definite integral divided by the interval length. 14. Arc length. The length of a curve can be calculated using a definite integral. 15. Surface area. The surface area of a three-dimensional object can be calculated using double integrals. 16. Probability. Probability density functions are integrated to find probabilities. 17. Physics. Integration is used in various physics concepts, such as work, energy, and momentum. 18. Economics. Integration is used in economic models, such as calculating consumer surplus and producer surplus. 19. Engineering. Integration is used in various engineering fields, such as structural analysis and fluid dynamics. 20. Statistics. Integration is used in statistical analysis, such as calculating moments and distributions. Mathematical properties. 21. Linearity. Integration is linear, meaning the integral of a sum is the sum of the integrals. 22. Constant multiple. The integral of a constant times a function is the constant times the integral of the function. 23. Reversing limits of integration. Reversing the limits of integration changes the sign of the definite integral. 24. Additive interval rule. The integral over an interval can be split into integrals over subintervals. 25. Comparison theorem. If one function is greater than another on an interval, its integral is greater. 26. Mean value theorem for integrals. There exists a point in an interval where the function's value is equal to its average value over the interval. Techniques and identities. 27. Integration by parts formula. Integral u dv equals uv integral v do. 28. Power rule for integration. Integral x caret n dx equals x caret n plus 1 plus c, for n does not equal minus 1. 29. Trigonometric identities for integration. Integral sin x dx equals cos x plus c. Integral cos x dx equals sin x plus c. Integral tan x dx equals ln sec x plus c, etc. 30. Exponential and logarithmic functions. Integral e caret x dx equals e caret x plus c. Integral 1 x dx equals ln x plus c. 31. Inverse trigonometric functions. Integral 1 square root 1x squared dx equals arcsine x plus c. Integral 1 plus x squared dx equals arctan x plus c, etc. 32. Integration of rational functions. Partial fraction decomposition. 33. Integration of trigonometric functions, using trigonometric identities and substitutions. 34. Integration of exponential functions, using properties of exponents. 35. Integration of logarithmic functions, using integration by parts or substitution. Numerical integration. 36. Riemann sum. Approximating integrals using rectangles. 37. Trapezoidal rule. Approximating integrals using trapezoids. 38. Simpson's rule. Approximating integrals using parabolas. 39. Romberg integration. A method for improving the accuracy of numerical integration. 40. Gaussian quadrature. A method for approximating integrals using weighted sums of function values at specific points. Advanced topics. 41. Improper integrals. Integrals with infinite limits or discontinuities. 42. Double integrals. Integrals over two-dimensional regions. 43. Triple integrals. Integrals over three-dimensional regions. 44. Polar coordinates. Using polar coordinates for integration in two dimensions. 45. Cylindrical coordinates. Using cylindrical coordinates for integration in three dimensions. 46. Spherical coordinates. Using spherical coordinates for integration in three dimensions. 47. Beta and gamma functions. Special functions related to integration. 48. Elliptic integrals. Integrals involving square roots of polynomials. 49. Fourier series. Representing functions as infinite sums of trigonometric functions using integration. 50. Laplace transforms. A technique for solving differential equations using integration. Historical context. 51. Leibniz and Newton. The development of calculus by Leibniz and Newton. 52. Early methods of integration. Methods developed by ancient civilizations. 53. Development of integration techniques. The evolution of techniques for solving integrals. 54. Applications of integration in various fields. The use of integration in different areas of knowledge. 55. Advances in numerical integration. The development of methods for approximating integrals numerically. Applications in real life. 56. Physics. Calculating work, energy, momentum, and other physical quantities. 57. Engineering. Designing structures, analyzing fluid flow, and solving problems in various engineering fields. 58. Economics. Analyzing economic models, calculating consumer surplus and producer surplus. 59. Statistics. Calculating probabilities, distributions, and statistical measures. 60. Probability. Finding probabilities of events using probability density functions. Mathematical connections. 61. Fundamental theorem of calculus. The connection between differentiation and integration. 62. Inverse operations. Integration is the inverse operation of differentiation. 63. Mean value theorem. Relating the average value of a function to its instantaneous values. 64. Taylor series. Representing functions as infinite sums using derivatives and integrals. 65. Fourier series. Representing functions as infinite sums of trigonometric functions using integrals. Problem-solving techniques. 66. Integration by parts. Using the product rule for differentiation in reverse. 67. Integration by substitution. Simplifying integrals by changing variables. 68. Partial fraction decomposition. Breaking down rational functions into simpler fractions. 69. Trigonometric identities. Using identities to simplify trigonometric integrals. 70. Integration of exponential and logarithmic functions. Using properties of these functions. Applications in computer science. 71. Numerical methods. Implementing numerical integration algorithms for solving problems. 72. Computer graphics. Rendering images and animations using integration techniques. 73. Machine learning. Using integration for training models and analyzing data. 74. Data analysis. Applying integration for statistical analysis and data visualization. 75. Computer vision. Using integration for image processing and object recognition. Miscellaneous facts. 76. Integration is the area under a curve, the geometric interpretation of the definite integral. 77. Indefinite integrals as families of functions. The concept of antiderivatives and their relationship to definite integrals. 78. Improper integrals and their convergence. The conditions for the convergence of improper integrals. 79. Double and triple integrals as iterated integrals. Evaluating multiple integrals as repeated single integrals. 80. Applications of integration in physics and engineering. The use of integration in various fields. Additional facts. 81 to 100. 81. The Riemann sum as a limit of a sum. The definition of the definite integral as the limit of a Riemann sum. 82. The trapezoidal rule and Simpson's rule. Numerical methods for approximating integrals. 83. The gamma function and its properties. A special function defined by an improper integral. 84. The beta function and its relationship to the gamma function. Another special function defined by an improper integral. 85. The Laplace transform and its applications. A mathematical transformation used to solve differential equations. 86. The Fourier transform and its applications. A mathematical transformation used in signal processing. 87. The Dirac delta function. A mathematical function used in physics and engineering. 88. The Fresnel integrals. Integrals involving trigonometric functions and square roots. 89. The error function. An integral related to the normal distribution. 90. The Liouville number. A transcendental number related to integration. 91. The Abel-Ruffini theorem. A theorem about the impossibility of solving polynomial equations of degree 5 or higher in radicals. 92. The Hilbert-Waring theorem. A theorem about representing natural numbers as sums of powers. 91 to 100. Additional facts. Mathematical theorems and concepts. 91. The Abel-Ruffini theorem. This theorem states that it's impossible to solve a general polynomial equation of degree 5 or higher in radicals, using addition, subtraction, multiplication, division, and taking roots. 92. The Hilbert-Waring theorem. This theorem asserts that for any positive integer k, there exists a positive integer g, k, such that every positive integer can be expressed as the sum of at most g, k, kth powers. 93. The fundamental theorem of arithmetic. This theorem states that every positive integer greater than 1 can be written uniquely, up to the order of the factors, as a product of prime numbers. 94. The prime number theorem. This theorem gives an approximate formula for the number of prime numbers less than or equal to a given positive integer. 95. The Riemann hypothesis. This is a famous unsolved problem in mathematics, which conjectures that the non-trivial zeros of the Riemann zeta function lie on the critical line. Applications in other fields. 96. Biology. Integration is used to model population growth, diffusion of substances, and other biological processes. 97. Chemistry. Integration is used to calculate reaction rates, equilibrium constants, and other chemical properties. 98. Geology. Integration is used to model geological processes, such as erosion and sedimentation. 99. Psychology. Integration is used to analyze psychological data and model cognitive processes. 100. Social sciences. Integration is used to analyze social data, model social phenomena, and predict future trends.